Welcome. Today we'll learn to solve the integral of e to the power of negative x times cosine of x using integration by parts. Let's start by reviewing the integration by parts formula. This formula can really help us tackle this integral, and let us understand why it's useful here. The idea of integration by parts comes from the product rule in reverse. We'll want to choose parts of our integral as u and dv. For this problem, let's choose u to be cosine of x so that dv is e to the power of negative x dx. Now, let's differentiate and integrate as necessary. The derivative of u with respect to x is negative sine of x, giving us du equals negative sine of x dx. And integrating dv, the integral of e to the power of negative x dx, gives us v equals negative e to the power of negative x. Now, let's substitute these into our integration by parts formula. So we have the integral of e to the power of negative x times cosine of x dx equals u times v minus the integral of v times du. Substituting these gives us negative e to the power of negative x times cosine of x minus the integral of negative e to the power of negative x times negative sine of x dx. Now, simplifying this expression gives us the integral of e to the power of negative x times sine of x dx. Notice that the integral we have resembles the original problem. That's why integration by parts is powerful, especially for cyclic integrals. Continuing, we apply integration by parts again on this new integral. Let's go through the process once more and choose parts. Now let u be sine of x and dv be e to the power of negative x dx. Differentiating the choice for u this time, we have du equals cosine of x dx. And integrating dv gives us v equals negative e to the power of negative x. Substitute these into the integration by parts formula again and simplify. We have negative e to the power of negative x times sine of x minus the integral of negative e to the power of negative x times cosine of x dx. This resolves back to our original integral, completing the cycle. Because we have returned to our original integral, adding the left-hand side of the original formula to both sides condenses the solution. Finally, solving for the integral, distribute the multiplication over the addition, and divide the entire equation by 2, we get the final answer. The integral equals negative 1 over 2 times e to the power of negative x times sine x plus cosine x dx plus c, where c is the arbitrary constant of integration. I hope this detailed explanation helped you understand how you can apply integration by parts, especially when facing cyclic integrals and solving problems. Thank you for watching, and happy integrating!